3, -3. Okay. Other than that, okay. All right. So this is going to be off a little bit. So this should be a -3. I already got 3, so I don't need 9/2. That makes more sense. That makes more sense. Okay. Oops, +3. Okay. So I plugged in -5. When I plugged in -5, because -5 is less than -3, I got a negative number. When I plugged in 0, which is in between -3 and +3, I got a positive number. And then when I plugged in, don't worry about the 5 here, the 5 was extra. And then when I plugged in 4, which is greater than 3, I still got a positive number. Meaning at 3, it doesn't do anything. It kind of pauses, but then it increases, keeps increasing after 3. Okay. So before -3, change this. So before -3, it was decreasing. And then in between -3 and 3, it's increasing. And then after 3, it's still increasing. That's why I said you got to check it. You can't take it for granted that, oh, this over here, oh, this is just going to be negative because it's negative, positive, negative, right? Can't take it for granted. Okay, that'll cost you. All right, you got to actually check it. So increasing from -3 on, decreasing from negative to -3. There's only a relative minimum. There is no maximum here. There is no maximum because it has a bottom at -3, but then it just keeps going and never stops. After -3, it goes, and then at 3, it kind of pauses for a little bit, but then it keeps going straight up. Okay? So the graph's probably going to look something like this. Something like that. Where at 3, it kind of pauses and it has 0. The derivative is 0, but then it keeps increasing. It doesn't go back down. So this right here is not a maximum or minimum. We only have one relative minimum. Okay, that's the first derivative stuff. Second derivative stuff. Second derivative, negative or positive 12x squared minus 24x minus 36. Factored that. I got 3 and -1. Those are inflection points. Those are going to be where it changes concavity. So you plug in -2. I plugged in -2. I actually plugged it in here because it's easier to plug it in here than it is up here. Because up here you got to square it and then multiply it times 12 and then multiply it times 24 and then subtract them and then subtract 36. Here, super easy. Subtract by 3, add 1, multiply by 12. That's a lot easier for me to do. That's what I did. I used when I used this guy here. Okay. All right. So based on that, concave up before -1 or after 3, and in between is where it's concave down. That kind of goes with my picture here. Concave up, and then at -3 it changes to concave, continues concave up, and then here, this is where it changes. So this is an inflection point here, right? In between, 3 is actually an inflection point. It's not a maximum or minimum, it changes from concave down to concave up. Okay. And then there's also an inflection point right here at -1. So this is -1, this is +3, this is -3. If it were on the graph, actually it would be more like this. Okay. So the only thing I haven't found is asymptotes. Is it going to have any asymptotes? Yes, no, maybe? No, yeah, why not? Why no asymptotes? Why is the original going to have no asymptotes? 2 words. There's exactly, it's continuous. Yeah, how do we know that? Exactly, it is continuous. How do we know that? 2 words. No division or no bottom. Yeah, no division or no bottom. There's no bottom to this. There's no division here, right? So it can't be. It has to be continuous everywhere. Okay. Like this guy here, the next one you look at, that one has some division. There is a bottom. So that one's going to have an asymptote, vertical asymptote. There's a place where it can't exist. Okay. All right, let's try, I want to try this one. We'll skip that one. Let's try this one. Another trig function. Okay. So what I want you to do now is find first derivative, second derivative. Do that first. Do that first. First derivative, second derivative. Start there. Good. If you don't have them memorized, take out your sheets so you can use that for derivatives and for values because we're going to need both. To find second derivative, we're going to have to use chain rule because it's secant squared. Okay, so I got both of my, got the first derivative, got the second derivative. What do I do next? So those are the things I need to find. Highlight, underlined in red. I need to find all of those things. Roman? How does the 2? So you talk about the first derivative? So, okay. So when I find derivative of this guy goes away. Okay. And so this is a -1. So you have -1, and then this is the part that's squared. So I did chain rule here. So move the 2 to the front and then repeated. And then I chained on the derivative of the inside, which is this guy here. And then this is all one term here. There's no plus, minus. It's all one term being multiplied here. So you just distribute it literally just once. So it becomes -2 secant squared tangent x. Okay. Okay, so what do we do now? Huh? Perfect. Okay. So let's do first derivative first. I'm solving for x, right? I'm solving for x. So anytime we want to solve for x, we want to isolate x. There's only one x here. There's only one x. That's it right there. So how do I isolate it? How do I, at best, I can't get rid of everything, but how do I, at best, get x by itself? What's the first thing I'm going to do? I want to isolate this guy here. This is the guy I want to isolate. Now, I'm not going to be able to isolate it perfectly, but I can isolate it somewhat. So what can I do first? There you go. That's the first step. Good. First step is subtract 2 from both sides. So we get -2 equals -1 or negative secant squared. Okay. What else can I do now? So I can't get rid of the x. I can't get rid of secant. I can't remove secant from x, but I can get secant of x. All I want on this side over here is secant of x. I don't want everything else. I want to get rid of. So what's the next thing, Isabel? I can't do that yet. What can I do first? That's what I was going to do second. Divide them by -1. So then you have 2 equals secant of x squared. Now, Isabella, what did you say? There you go. Square root both sides. Square root both sides. There we go. So you're going to get positive and negative square root of 2 because you're taking the square root and we're solving. Anytime we're solving and you take a square root, it's got to be a positive and a negative. Okay, so secant of x is isolated. That's as best as I can do. I can't get x. I can't separate these two because they're not able to be separated. It's not like multiplication or division or addition. Like they're one. Okay, so that's good enough. So what do I do now? How do I find out? How do I solve for x? How do I solve for x? Even easier than that. Look at your table. The table has answers. Your table has answers. This is full of answers. This guy right here is full of answers. I'm trying to figure out where this is true. So I'm going to write down all of the values where that is true. So secant square root of 2, it's true at pi over 4. It's also true at 7 pi over 4. Okay. Oh, negatives. I forgot the negatives. The negative, it's negative 3 pi over 4 is negative square root of 2. And there's one at 5 pi over 4. Okay, so that's where all of them equal positive 2 and negative 2. Okay, so what should I do before I start going to the first derivative test and look for increasing, decreasing? What should I do first? There you go, yeah. Interval, interval, interval. Only goes from 0 to pi. Only goes from 0 to pi. Okay? So anything that's not in that interval, I don't want. So 0, the only one from 0 to pi, the only one that fits that is pi over 4. Oops, no, 3 pi over 4 fits. Yeah, 3 pi over 4 fits. The other two are too big. Okay. So let me go. Now I'm going to create number line pi over 4, 3 pi over 4. Okay. So as I do these problems, am I changing any steps? Have we been doing the same steps from the first problem to this problem? We've been doing that, right? That's what I'm asking you to do. Now, I understand some of these, some of these trig stuff can be a little different, and some of the E stuff can be a little different, but your steps are the same, right? So when I ask for the steps, you should know the steps. Now, how to do those steps, sometimes we get a little tripped up. That's fine. That's part of math, okay? That's part of the challenge. But the steps you should know. So how do we find increasing, decreasing? Find the first derivative, set it equal to 0. Once you get that first derivative test, do your number line, find out if it's positive or negative, increasing or decreasing. You should know that, okay? That's the part I expect you to know, okay? Okay, now we got to figure out if it's positive or negative, increasing or decreasing. So take the first derivative. First derivative is 2 minus. So I'm going to check 0 because that's less than pi over 4. Something in the middle is pi over 2. Pi over 2 is pretty. And then the other one I'm going to check is pi. Nice round, even things. Okay. Well, if you have your chart, super easy because the first derivative is right here. So you just plug in 0 here. What's secant of 0? 1. 1 squared is still 1, right? 2 minus 1, positive number. Positive number. Okay. Pi over 2. What's secant of pi over 2? 0. Okay. So 0 squared is 0. 2 minus 0, still positive, right? Oh, pi over 2, secant of pi over 2 doesn't exist. So it's 2 minus a number that doesn't exist, right? Okay. Wait, I shouldn't pick that number then. If it doesn't exist, I should pick a value that exists. So let me pick another value that does exist. Let's see, pi over 3. Pi over 3. So when I plug in pi over 3, secant of pi over 3 is positive 2. Wait, what? Oh, okay, yeah, that's right. Secant of 3 is positive 2. pi over 3, sorry. Secant of pi over 3 is positive 2. Positive 2 squared is 4. 2 minus 4 is a negative. So it's actually negative. So good thing I checked a different number. If that happens, check another number in between there. Okay. Pi. Secant pi. Secant of pi is negative 1. Negative 1 squared is 1. 2 minus 1, positive number. Okay. So now we can tell where it's increasing, where it's decreasing, where is there going to be a maximum, where is there going to be a minimum. Okay. Second derivative. Second derivative. Second derivative is, let me rewrite it. Okay. That's the second derivative. So I got to set that equal to 0. So it was negative 2 secant squared of x tangent of x. Again, I have two x's, and I can't separate them from secant and from tangent, but I can do a couple things. I can get rid of everything else. What can I do to help make this a little bit easier to isolate x? Again, I'm not going to be able to isolate x perfectly, but there is something I can do. Yep, divide by negative 2. That becomes a 1, and this still is 0. So now that negative 2 goes away. Okay, so I have to find a value that when I find the secant and square it, divide secant squared out. Oh, so let's see. No. Okay, so you're talking about doing this. Oops. So multiply one of them, you said? Well, then could I do it with everything? Couldn't I do it with everything, you know? Then everything would be 0 equals 0, right? So we can't do it with those. It's good thinking. I like the thinking, but yeah, that doesn't work because then with that we could divide everything. We could divide the coefficients definitely with doing that, but we can't divide that. Yeah. Okay, so what we have to do is figure out where between is this true. So where I so if I were to take a secant, square it, and multiply it times a tangent, would I get a 0? What has to be true there? So if this times this equals 0, what has to be true? One of them has to be 0, right? So go look, where is secant or tangent 0 in between there? And that's going to be one of our answers. So where is secant or tangent equal to 0 from 0 to pi? Pi? At pi, tangent is 0. Is there anywhere where secant is 0? Nope. And is there anywhere else? 0, also 0, right? Tangent is 0 at pi, at 0. Right? Those are our critical values. That's where we're going to have inflection points. Those are our inflection points. I should probably reverse them and put them in order. 0, pi. Okay. Jessie, now have your focus up here. If this is too easy, let me know. I can pick some different stuff. Okay. All right. Okay. So now what I'm going to do, plug in, find out if it's concave up or concave down. Okay, so just for lack of time, that's what you're going to do. And one other thing. So that'll tell you the last things you need to know. Concave up, concave down, right? 0 and pi are going to be where we have inflection points. One last thing though. Vertical asymptotes. Is there going to be a vertical asymptote here? When do we get vertical asymptotes? When there's fractions, which makes it on the, where's 0? 0 has to be where? On the bottom, right? When we get 0 on the bottom, what is that called? Undefined, right? Is there anywhere where this guy is going to be undefined? Where is it going to be undefined from 0 to pi? Pi over 2. Pi over 2. So there's going to be a vertical asymptote at pi over 2. If I plug in pi over 2 to tangent, I'm not going to get an answer. I'm going to get undefined. So we have a vertical asymptote at pi over 2. Okay? And that'll be how you get the rest. All right. Okay, so these problems kind of took a little longer than I thought. I'd rather do that than not do them. So there is an assignment posted. It's not due till Friday. Now, again, I won't see you guys the rest of the week. So make sure sometime between now and Friday at 11:59, you do that assignment. Okay. Yep, that's about it. Okay. All right. Have a good weekend, guys. I will see you guys on Monday.